Welcome to Eureka Math. I'm Mr. Schenkel. This is 8th grade, Module 4, Lesson 2. Let's get started. Okay, today we have to decide if the equation given is true given a solution. So in this case, number one, it tells us that x is -3. So -3 is a solution to the equation. We have to decide whether that's true or not. So all we're doing here is using substitution. We're going to use the original equation that we have, and every time I see an x, I'm going to substitute -3. So I'm going to put this -3 in. And then we'll simplify it and decide if it's a true statement or not. So let's do that. We have 6 times -3 plus 5 equals 5 times -3 plus 8 plus 2 times -3. Okay, and then we're just going to simplify. So let's go through and get all this multiplication done first. 6 times -3 is a -18 plus 5 equals 5 times -3 is a -15 plus 8, and then 2 times -3 is a -6. And now we can combine our integers. A -18 and a +5 is a -13 on the left side. And on the right side, let's see, the -15 and the -6 gives us a -21. And then add 8 to that, a -21 and a +8 gives us a -13. And since -13 does equal -13, then we can say, yes, this is a solution. -3 is a solution to that equation. Number 2. Does x equals 12 satisfy that equation? So we're going to do the same thing, use substitution, and rewrite our equation. 16 minus 1/2 times 12 is equal to 3/4 times 12 plus 1. All right, the multiplication is first. So we get 16 minus 1/2 times 12. Well, that's 12 halves, and 12 divided by 2 is 6. Is equal to 3 times 12 is 36, and 36 divided by 4 is 9. Plus 1. 16 minus 6 is 10 on the left side, and on the right side, 9 plus 1 is 10. 10 equals 10 is true, so x equals 12 does satisfy the equation. It's a solution. Number 3. Chad solved the equation given and is claiming that x equals 2 makes the equation true. Is Chad correct? Well, the way we check is we just substitute a 2 for x. So rewriting the equation, we have 24 times 2 plus 4 plus 2 times 2 equals 3 times the quantity, 10 times 2 minus 1. Every time I see an x, I put a 2 in. Okay, and then order of operations. We can kind of do this in a row here. 24 times 2, that's 48, plus 4, plus 2 times 2 is 4. There's our left side. On the right side, I need to do this 10 times 2 first, so that's 20 minus 1 is 19, and 3 times 19 would be 58. All right, and then simplify the left side. 48 and 4 is 52, and 52 and another 4 is 56. Does 56 equal 58? No, it does not, so 2 is not a solution. 2 does not make the equation true. Number 4. Lisa solved the equation x plus 6 equals 8 plus 7x and claimed that the solution is x equals -3. Is she correct? Well, let's find out. Every time I see an x, I'm going to put in a -3. So we have a -1/3. -1/3 plus 6 equals 8 plus 7 times negative 1/3. Okay? Let's see, 6 plus a negative 1/3. Oh, not fun, right? Well, it's a lot easier if we make the denominators the same. So I'm going to change this 6 into a number with a denominator of 3. In order to do that, I just need to multiply the top and the bottom by 3, and that gives me negative 1/3 plus 18/3. And now it's easy to add these. A negative 1/3 and a positive 18/3 gives me 17/3. So there's the left side. On the right side, I'm going to multiply first, so I get 8 plus 7 times negative 1, that's a negative 7/3. And same idea here, we're going to multiply the 8 by 3 over 3. 3 over 3, and that's going to give me 24/3 plus a negative 7/3. 24 minus 7 is 17/3. So 17/3 equals 17/3. Yes, Lisa is correct. Negative 1/3 is a solution to that equation. Number 5. Angel transformed the following equation from 6x plus 4 minus x equals 2 times the quantity x plus 1 into 10 equals 2 times the quantity x plus 1. He then stated that the solution to the equation is x equals 4. Is he correct? Well, let's take this original equation, 6x plus 4 minus x equals 2 times the quantity x plus 1. So let's simplify the left side and see if we get 10. Let's see. Well, 6x minus, I can combine like terms, 6x and a negative 1x. That's 5x plus 4 is equal to 2 times the quantity x plus 1. We won't change that side. Now, I didn't get 10, right? I got 5x plus 4. So right now it looks like no. But let's throw in the solution. Let's throw in the x equals 4 and see what we get. So every time I see an x, I'm going to plug in a 4, substitute a 4. So this is 5 times 4 plus 4 equals 2 times the quantity 4 plus 1. All right, left side we get 20. 5 times 4 is 20, plus 4 is 24. And on the right side, I get 4 plus 1. I have to do that in the parentheses first. 4 plus 1 is 5, and 5 times 2 is 10. 24 equals 10 is not correct. So Angel's transformation was not correct. Should have been 5x plus 4 on this left side. And since that's the correct transformation, x equals 4 didn't work because 24 does not equal 10. Number 6. Claire was able to verify that x equals 3 was a solution to her teacher's linear equation, but the equation got erased from the board. What might the equation have been? Identify as many equations as you can with a solution of x equals 3. Well, I'm not going to identify as many as I can because that would be an infinite number of equations, and here's why. Let's just say we start with x equals 3. Well, I could make another equation just by using any multiple on both sides of the equal sign. So let's say I multiply the left side by 2, and I multiply the right side by 2. 3 times 2 is 6. 2x equals 6 also has a solution where x equals 3. And if we continue that, I could say, well, what about 3 times both sides? 3x equals 9 has a solution of x equals 3. 4x equals, 4 times 3 is 12. That's a solution of 3. 5x equals 15. That has a solution of 3. And you can see that all I have to do is choose any of the infinite possibilities of multipliers, And I'm going to get an equation that also has a solution of x equals 3. So there are an infinite number of possible equations that you could write. These are just a few of them. And I don't have time to write them all. Neither do you. Number 7, does an equation always have a solution? Could you come up with an equation that does not have a solution? Well, yes. If I can make two sides of my equation different, where x has to be something different, then I can actually make a lot of these. So let me give you an example. Let's say 2x plus 1 equals 5 minus, I don't know, 3x. Okay, that could be one where I would say, well, let's say that x is 5. X is 5. Well, if I say x is 5, then I get 2 times 5 plus 1 is equal to 5 minus 3 times 5. Okay, and on the left side, that's 10 plus 1 is 11, is equal to 5 minus 15, that's a negative 10. Does 11 equal negative 10? No, that's not a solution. Is there no solution? So if we set this up where we could find out what x is, maybe there is. So let's see. 2x plus 1 equals 5 minus 3x. 2x plus 1 equals 5 minus 3x. That's our original equation. In order to solve this, I need all of my x's on the same side, so I'm going to add 3x to both sides, and that gives me 5x plus 1 equals 5, and then I could subtract 1 from both sides, and that gives me 5x equals 5 minus 1 is 4, and then multiply by reciprocal, and what do you know, x equals 4/5. So that does have a solution. Could you come up with an equation that does not have a solution? Maybe not. We'll talk in class about that one. All right, that is lesson 3. Hope that helps. See you again next time.